seconds until you stop. Okay? So remember that X is the time and Y is the position. And position is also...
Can you read it one more time?
Yeah. Do you want to draw your graph first so you can... Yeah. That might be easier, and then you can like think about it. You can also do some measurements on the bottom of your time, like 5 increments since it's 5 and 10. So, one more time. You get into a car and accelerate for 10 seconds until you reach a constant speed. You stay at this speed for 10 seconds. Then you slow down for 5 seconds until you stop. Speed? Oh, I'll tell you that.
So you're accelerating for 10 seconds. Alright, so
is this one time?
okay, this one's time. And then main constant for 10.
And then you slow down for 5 seconds until you come to a complete stop.
Close. Main constant for 10. And slow down for 5 seconds.
I guess we would do the...
Yeah. So you both pretty much put the same thing down, and our graph is going to look a little different from this one because that's how I did it when I drew it out too. You could do it with curves, but you don't need to do that. You all did it right. Time, position. One thing you could have done differently is I never really said where the car started, so you could have started all the way up here and just accelerated to 10. Doesn't really matter because I never said that you started with 0 speed. So just a few questions. Does anyone have a misconception that they might think when it comes to motion? So one big thing I know when we went over the topic the other day in class is that everyone in my group was like, you guys, everyone was like, oh, like motion means that you're moving. Like every time you have motion, you're moving, which is not true. One of the best examples that you can show is that if I am thought I was really organized, but I guess not. Oh well, I know how to explain it. So if I put these papers on the table, they're not moving, are they? But do they have motion? Yes, because gravity is a form of motion like we talked about earlier. So gravity is pulling these down, while the table isn't pushing them up in another force. So there's 2 forces occurring on this, and neither of them are causing it to move. So motion doesn't necessarily have to have a moving force. So yeah, that's a big one. So can anyone explain like what we talked about today, or like something new that you learned?
I just learned what you just explained. Like, the papers aren't moving.
Yeah. And that's like a difficult one to like process because you're like, what?
Yeah.
Obviously. But yeah, so you have to make sure like that when you're thinking about motion, you understand that there has to be a force there for something to have motion. Like, yeah. That's all I have to say. Sorry if that was bad.